VSWR, or load mismatch ruggedness, has always been a prime consideration when selecting MOSFET devices for use in high-power amplifiers. Microsemi's line of VRF devices was developed to address this need. This is a demonstration of the ruggedness and capability of the VRF series of power MOSFETs. In this demonstration, we will run an amplifier that uses Microsemi's VRF2933 300-watt VDMOS devices in the very worst of SWR conditions to show its considerable ruggedness capabilities. While all VSWR tests are conducted using the same basic test setup, the operating conditions and performance claims will vary between manufacturers. The ruggedness test setup is quite simple. A signal generator provides the basic test carrier signal. This test is at 30 megahertz, using a carrier signal modulated to 1 millisecond pulses at a 20% duty cycle. This signal is amplified by a laboratory amplifier to about 8 watts, the required drive level to the amplifier being tested. The output of the amplifier goes through a coaxial switch, where the output can be directed to either the VSWR test load or to a standard 50 ohm load and power meter. The short piece of low-loss coax used to connect the switch still provides greater than 100:1 VSWR at 30 megahertz. The test amplifier is a broadband push-pull circuit using two Microsemi VRF2933 VDMOS devices. The amplifier has been tuned to provide 1200 watts at 30 megahertz. The amplifier is mounted on a water-cooled heatsink. First, we will show the performance of the amplifier operating on 50 volts into the 50 ohm load. The output is slightly greater than 900 watts. However, to demonstrate the ruggedness of these VRF2933 parts, we will now operate the amplifier on 65 volts, and so the output power is now more than 1200 watts. The first test is the intermittent open-short test. This is made more visible by using a screwdriver to short out the open center conductor of the output coax. After the test, the amplifier is returned to the 50 ohm load to check the output. It is still the same 1200 watts. Next, we will apply a hard short circuit to the amplifier. We turn it on, turn it off, and switch over to the 50 ohm load. When turned back on, it shows the output is still greater than 1200 watts. Finally, we test the amplifier with a controlled mismatch that can vary the load through all phases. To show this, we first connect the tunable load to a network analyzer. Here we see that by changing the control circuit, we can vary the phase of the reflection coefficient all the way around the Smith chart. Over this range, the VSWR varies from a minimum of 75:1 to more than 100:1. The load box is then connected to the amplifier through the switch. Turning the amplifier on, we now vary the load tuning over the complete range. Now we turn it off and switch back to the 50 ohm load. We see that the output power has not changed. Well, perhaps it's a little bit higher now that it's warmed up. We hope you have enjoyed this demonstration of the VSWR ruggedness of Microsemi's VRF2933, a most capable VDMOS part that was first introduced in 2008. While other competitors work to match this level of performance, Microsemi has been doing it for years.